Good day everyone, I am Kathy Kahulugan Penido, and today I am going to explain the concept of group homomorphism. So a homomorphism is a relation phi from a group G star to another group G prime star dot such that for each element A in G, there corresponds to an element phi A in group G prime and phi A dot phi B for all A and B is an element of G. So this is how we define it in statement. Let's understand it. Suppose we have group G here with its binary operation, and we have group G prime here with its another binary operation. Then a homomorphism is a relation of group G to group G prime. And we were going to see if this relation is a phi. Now to know if this relation is a phi, we need to satisfy this condition. We say we put A in group G. So we need to have phi A in group G prime. Now we know that G is a group. We say we put A and B in this group, so we must have A star B on the same group. Now, due to this condition, we must have phi B in group G prime and phi A star B in group G prime. So since we already satisfy this condition, now we need to know if this phi is a homomorphism. So we can only satisfy if a phi is homomorphism if and only if phi A star B is equals to phi A dot phi B. So mainhan nimo if ang phi is homomorphism if masatisfy ni nga condition. And take note that star is a binary operation of group G and dot is another binary operation of group G prime. Kintahay manotice ninyo nga kani nga phi is homomorphism, so we call it homomorphic. Or we can say that groups G and group G prime are said to be homomorphic. Next are the properties of homomorphism. First is operation preservation. A core property of homomorphism. If F is a homomorphism from group G to group H, then for all elements A and B in G, F A star B is equals to function of A star function of B, where star represents the group operation, which might be addition or multiplication depending on the group. So, kaning operation preservation is mao ni nga condition. Then, next is the identity preservation. So, homomorphism maps the identity elements of the first structure to the identity element of the second structure. Since kiba naman taon sa ning identity preservation, so no need na ningi i-explain o maadyo. Then, ang third property is the inverse preservation. So, homomorphism map the inverse of an element in the first structure to the inverse of its image in the second structure. So, to fully understand these properties of homomorphism, maghatag may example nga i-discuss ni Lloyd.
Okay, thank you, Kathy. Now, to fully understand the homomorphism, let us have an example. Example 1, which is pi a equals 2a. From the function pi, which is z, or integers under addition, maps to 2z, or the multiples of 2 in the integers under addition. Step 1 is the homomorphism property, which is pi a plus b equals pi a plus pi b. Now, let's have a given integers or numbers. Let us say a equals 3 and b equals 4. Now, let's substitute each numbers into the equation. So, pi 3 plus 4 equals pi 3 plus pi 4. Now, 3 plus 4 is 7. Then, which is pi is 2a. So, 2 times 7 equals 14. And then other side, also 2 times 3 plus 2 times 4 is 6 plus 8, which is also 14. Now, this is equal. So, let us say that, it satisfies that step 1 is a homomorphism. That pi a equals 2a is homomorphism. Now, step 2, which is the identity preservation, the identity element of z under addition is 0. Because any number that you add to 0 is still the same number. So, it's the identity element. Then the identity element for 2z under addition is also 0 because it's addition. Okay, so it's easy to understand or to see that it is a identity preserved in step 2 because it has both addition in their operation. So step 3, which is the inverse preservation. So pi equals negate a equals pi a. Now let's say that a equals 5. So pi negative 5 equals negative pi times 5. So 2 times negative 5 equals 2 times 2.5. So it is negative 10 equals negative 10. So it also preserves because the inverse is preserved. Pi negative a equals negative pi times a. So we can say that pi a equals 2a is a homomorphism from z under multiplication to 2z under, z under addition and 2z under addition, and its preserved identity and inverse. That's why it is homomorphism, because it satisfies the 3 steps: the homomorphistic properties, identity preservation, and inverse preservation. Now let's have another example. Pi times a equals pi, a plus 1. So our pi here is 1. To satisfy that, we need to follow 3 steps: the homomorphistic property, the identity preservation, and inverse preservation to conclude if this element or this function is really homomorphism or homomorphic. Now, for the homomorphism property, which is pi multiplied by a plus b, is it really equal to pi times a plus pi b? Now, suppose we have the numbers 2 and 3 as a and b. Now, pi multiplied by our a and b, which is 2 plus 3, is equal to pi 2 plus pi 3. Let's remember that pi is equals to 1. Now, 5, which is 2 plus 3 plus 1 equals 6. Then on the other hand, 2 plus 1, which is our pi, is 3. Then 3 plus 1 is 4. 3 plus 4 is 7. Now, as you can see, it is not really equal. So, pi does not satisfy homomorphism property because dapat ni siya equal. Now, for step 2, the identity preservation, we know that the identity element for all integers under addition is 0 because all numbers, if you add up to 0, will equate to the same number. Now, in this case, pi a is equals to a plus 1, which is 0 plus 1. It is 1 because we let a equals 0. Now, the identity is not preserved. Why? That's your assignment. Now, for step 3, the inverse preservation. The inverse preservation, which is pi multiplied by our negative a, is it really equal to negative pi times a? Let us see. If we have a number 5 that is an integer that we suppose 5. So, pi times negative 5, which is negative a, is it equal to negative pi times 5? Let us see. Negative 5 plus 1 is negative 4. While 5 plus 1, negative is negative 6. So, you can see that negative 4 is not really equal to negative 6. So, pi negative a is not equal to negative pi a. the inverse is not preserved because it is not equal. So we can say that pi a equal to a plus 1 is not a group homomorphism from the homomorphism condition fails. Identity and not preserved, inverse are not preserved. So we can say that it is not really homomorphism because it doesn't satisfy the three steps in finding the homomorphic equation. And we are your reporters saying stay curious and love exploring algebra.